room acoustic modelling. I wanted to give you just a short history of room acoustic modelling, digital modelling for room acoustics. After we went away from using physical scale models to determine the acoustic properties of the space during the design stage, we moved on to the first version of digital modelling called ray tracing in 2 dimensions. And MATLAB software was the common software to use, where we could generate a script that would allow us to look at the angle of incidence and reflection of reflectors in performance spaces. So the process involved hand tracing paper architectural drawings and scanning those in through a photocopying machine. The scanned drawings were then imported into the computer software package, in this case MATLAB, to undergo a ray tracing analysis to assess the reflection pattern for different sound source locations in the auditorium. You can see an output or one of the images from this 2D ray tracing on the left-hand side here. So the red dot here indicates a location on the stage where a performer might be, and the green rays firing towards the reflectors are the direct sound from the performer's mouth hitting the reflectors, and the purple rays are the reflected rays going back towards the audience areas. As you can see, you can change the angles of these reflectors to get different sound projection towards different parts of the audience. And in performance spaces, the location of these reflectors are critical to how they reflect sound to different parts of the audience. And as you can see here, we can use the 2D ray tracing method to manipulate or change these angles subtly to see where we get the reflections of sound towards the different areas of the auditorium, including the stalls area and the balcony areas. The green areas here are noted to be absorptive surface finishes. So in these days, when we used to do the 2D ray tracing, you could either make the surface reflective or totally absorptive. And in this case, we would expect that the stalls area and the balcony area would be absorptive because it would be occupied by people in the audience. Usually distant surfaces away from the stage area are also absorptive just to provide general reverberance control. So that explains why the surface finishes here are noted green and the surface finishes near the stage area are noted black for reflective. Following the MATLAB 2D ray tracing analysis, we moved on to using 2D ray tracing in AutoCAD software. And this is the planned drawing of a university auditorium in the US that I worked on, where we had an architectural design including pocket windows along the side walls of the auditorium here. So the idea architecturally was to get visual connection to the outside, which was a beautiful campus-style scenery. And the architect thought it'd be great to have transparent panels on the side walls of the auditorium. But unfortunately, when we did a 2D ray tracing analysis, what we found is that there were the purple rays of the direct sound coming out from the stage area towards the pocket windows, but we'd get this striated pattern or irregular pattern of reflections back towards the audience area shown by these light blue lines. What this would culminate in the auditorium are hot and cold spots of sound, which would be very distracting to some people in the audience because they might not be able to hear clear and intelligible speech coming from the stage area. So we consider this to be an uneven dispersion of sound reflections, which is undesirable. What we do want to get is the same acoustic experience for everyone in the auditorium. So what we did is we'd made the side walls totally straight. There were still windows in line with the side walls, but they weren't pocket windows. So we would get specular reflections of sound from the stage area to the audience area. And as you can see here, the reflection pattern shown by the light blue lines is a lot more even across the whole auditorium area, where the audience would get a much better acoustic experience. Following the evolution of AutoCAD software, we started doing 3D ray tracing, and you can see for the same auditorium example I showed in the previous slide, what we were able to do is visualize 3D ray tracing in a much more graphical manner and a lot more illustrative to the architects and to the designers of the auditorium. On the right-hand side here, it shows that planned section of the auditorium again, and you can see the pocket windows and the uneven dispersion of sound reflections across the audience. But in 3 dimensions, it's a lot more illustrative. You can see the height dimension as well as the planned dimension that I showed you before.